The slope of the trail plays a critical role in how water moves across it. A trail that's too steep will channel water down the trail, causing erosion. And a trail that is located in flat areas can result in water pooling on the surface.
We're thinking about how is the water flowing? How do we get it to slow down but still flow off of the trail? Because anytime it's puddling on the trail or it's poorly draining soil, there are also impacts there. So how do we minimize impacts and maximize fun and enjoyment? And that's what this trail's for.
Measuring slope, how much the trail or surrounding landscape rises and falls over a certain distance, is necessary to predict how water will interact with the trail. This includes both the slope of the trail itself and the side slope, or hill slope, of the surrounding terrain. This is where the clinometer comes in. The clinometer is a handheld tool used to measure slope.
The clinometer is really important for both trail assessment and trail planning and design because we're all about trying to keep water off the trail, and depending on our soils, that's going to dictate how steep of a slope will be a sustainable trail tread. So by being able to measure the side slope of the hill we're on, as well as the slope that we want the trail to be for the tread, we can design a sustainable trail, and it's all based on grade.
A clinometer typically has two scales, percent grade and degrees. Most trail professionals and managers use the percent grade scale. A positive 10% slope means that the trail climbs 10 feet for every 100 feet in length, and a negative 10% slope means the trail descends 10 feet for every 100 feet in length. Always use a clinometer to find the grade. Never rely on your eyes or guesswork. Even small errors can lead to long-term drainage and erosion problems. Trail professionals never head into the field without a clinometer. Here's how it works. Begin by holding the clinometer up to your dominant eye, using the hand on the same side of your body as that eye. Look through the viewfinder and locate the percentage scale.
For the clinometer to work well, you have to both see the environment in front of you as well as what's in the clinometer. And so that's why you have to have binocular vision, both eyes open, to be able to see the line and the wheel of the grade of the clinometer superimposed over what you're seeing with your natural eyesight.
Work with a partner to establish a reference point for a zero grade. Stand toe to toe on level ground. Your binocular vision will naturally superimpose the clinometer's horizontal line across your partner's face or body. That spot becomes your reference point for a level or 0% grade. If you're the same height, the line will usually fall across your partner's eyes. Some trail professionals also use a flag tied to a tree at their eye level. These can make it easier to locate your reference point, especially when visibility is limited by vegetation. Now, you can measure percent grade on a trail or hill slope. Stand approximately 25 feet apart from your partner. Sight the horizontal line on the same reference point you established earlier. Read the percent grade shown on the clinometer. A professional uses the clinometer to ensure that the trail grade remains within a sustainable range. Soil composition, climate, designed use, and number of users are a few key factors that determine sustainable grades for a trail. For example, the maximum grade on a trail where the soil is 90% rock is much higher than a trail where there is predominantly sand.
For us, when we're doing design, that aspect of what type of soil does dictate things like how steep we can go and how frequent we need to drain things.
To get familiar with sustainable trail grades on a particular trail, use a clinometer in the field to measure percent grade on a sustainable trail segment and compare the grade to an eroded segment. The comparison will give you an idea of the maximum threshold for trail percent grade. The maximum sustainable grade refers to what the local conditions can withstand for small segments of trail. However, the targeted average grade of the trail should be less than the maximum grade as rolling contour alignment is designed. One general concept that can guide trail layout is the half rule. This rule states that the trail grade should never exceed half the grade of the hill it's built on. For example, if the hillside has a 10% slope, the trail should be no steeper than 5%. Trails with grades more than half of the maximum hillside slope discourage sheet flow across the trail and can result in water flowing down the trail. The half rule becomes less relevant on steep hillsides, where the maximum sustainable grade is dictated by other conditions. Measuring and analyzing slope is the foundation of sustainable trail design, but it's only one part of the equation. Trail professionals also assess how soil, climate, intended use, and visitor volume interact throughout every phase of trail development.
I just love learning about all these site-specific techniques that grow out of different geographical regions to counter the issues that are specific to that place. You know, whether you're dealing with non-compressible soils in the east side of the Sierra Mountains in California, or you're working in the southeastern part of the country where there's, very fine red soil, that red clay that's extremely hard when it compacts.
Measuring slope gives us the data, but experience gives us wisdom. By applying the fundamentals and adapting to each landscape, trail professionals develop trails that minimize impact and maximize experience for generations to come.